All right, Math 5130. Going to jump into non-parametric statistics or non-parametric tests. I don't want to spend a lot of time on this. I've probably blown your mind with two-way ANOVA. That's enough. But I do think you need no, I don't think. I know as a researcher in the health sciences field that you need non-parametric tests on your radar. Do you need to leave this class an expert at non-parametric tests? No, you're not going to leave this class as an expert in any of the ANOVA regression, any of the stuff that I teach you. It's just that you have this on your radar, and you know it exists, and you know when to use it. So if you remember the last in the two-way ANOVA, I used this systolic BMI over age. I'm sorry, systolic over BMI category and age. Did a two-way ANOVA and ad nauseum and all that. So, but if you recall, there were normality and equal variance assumptions for comparing the means of systolic blood pressure over age. So what I want to do is I want to dive into that a little bit. I'm going to completely ignore the BMI category here and teach you, or at least illustrate to you, non-parametric statistics. So a little bit about these things. First of all, they are distribution-free tests. All of these p-values that we calculate for ANOVA and next lesson and regression and t-test and you know, everything that I've taught you depend on some underlying probability distribution, some parametric test, right? It could be the t-distribution. If we've seen the f distribution, we've seen the chi-square distribution, and there are more. Well, those are the probability distributions that lurk out there somewhere. Let stat geeks like me worry about that stuff. But they lurk out there somewhere, and they model your phenomena. And you calculate your p-values and your confidence intervals from those. Now, here's the deal. When you violate assumptions, the p-values that you calculate may be incorrect. So a way to control for that, a way to address that, is when we have an extreme violation of assumptions, we may consider non-parametric tests. We definitely, not trying to scream at you here, please excuse my all caps, I hate that. I'm actually the president of an HOA here at the lake where I live, and our secretary, and she's older, but she writes everything in caps and it just annoys the heck out of me. But anyway, definitely when you have a dependent variable that is from survey data, like Likert data, you know, disagree, strongly disagree, no opinion, agree, and strongly agree, which are coded as like 1 through 5. They're really not 1 through 5. That 1 through 5 is just a coding for those responses. You would definitely use non-parametric tests. The only two non-parametric tests that I'm going to report to you, and that I want you on your radar at least, is what we would call a two-sample independent t-test, or an independent samples t-test. The corresponding non-parametric test to this is a Mann-Whitney. So if I had some survey responses that I wanted to see if the responses were different across gender, and gender was coded as male and female, that would be a lot like a two-sample t-test, but because it's survey data, we use a Mann-Whitney test. If I was running a two-sample independent test and I checked my assumptions and they were violated tremendously, then I would consider a Mann-Whitney. ANOVA, if we have something quantitative over a categorical variable with more than 2 levels, we'd run an ANOVA in parametric world. The non-parametric world, we use what's called a Kruskal-Wallis Wallace test. And there are many, many, many more. Sandrake, Wilcoxon, just many more of these tests that we could run. And again, you're not going to be an expert on this stuff. I just want you to have this on your radar. All right, so when do we use, again, when there's extreme violation of assumptions? I tell you, when I am running a t-test and ANOVA, two-way ANOVA, if I have a large sample, Typically 100 or more, I just go ahead and proceed with parametric test, even in the presence of a violation of assumptions. But I never, ever, ever use parametric test with survey data. Anytime I have survey data, I always use a non-parametric test. In fact, I worked with actually, I've worked with two mattress companies, which is really crazy, Sealy and Posturepedic. I think it was Posturepedic. I know it was Sealy. And had a student working on her doctorate under me, and I was her statistics advisor. I served on her doctoral advisory committee, and she was doing some survey data on some something with mattresses. I forget what it was, but we dove into the non-parametric world. All right, so disadvantages. Non-parametric is not near as cool. It's kind of like when you ask somebody what they did, kind of research, and like, what kind of statistical techniques did you use? Well, I used non-parametric, and you're like, oh, okay. There's less power, and I'll probably demonstrate that in just a second. So the process, I won't go into it a lot, but I want you to kind of have this presented to you at least once. We rank our data. Our focus is on the sum of the ranks. Our test statistic is quite ugly, and then we use the chi-square distribution to calculate the p-values for the test statistic. Fortunately for us, we will do all this stuff using technology. So the variables, I want to examine the differences in systolic blood pressure over age category. And again, if you recall, the assumptions were violated, and I'll demonstrate that again in just a second. So we shift our gear shift our focus from the means to the median. So for a non-parametric ANOVA, for the test that the Kruskal-Wells, our null hypothesis is no longer that the means are equal, it's the medians are equal. And then we have this rank sum thing lurking around in the background that plays a role. The alternative hypothesis is comparable to the parametric test in that at least one pair are different. Set alpha 0.05, if we reject the null, we have statistical significance, and we dive into post hocs. All right? So let's see how it kind of takes effect with this. So